In this video, we're going to discuss simplifying radicals or square roots when the radicand is a number. When you have the square root of some number, what you're really saying is that there is some different number that when you multiply that number by itself, you're going to get what's inside the square root. For example, let's say we have the square root of 4. Is there some number that we can multiply by itself to give us 4? And there is. If we multiply 2 by itself, it will get 4. So the square root of 4 is 2. But let's say we have a number, the square root of 5. Is there any number that we can multiply by itself that will give us 5? Let's say we try 2 times 2. 2 times 2 is 4. So we can't multiply 2 by itself to give us 5. Let's say we try 3 times 3. 3 times 3 is 9. So we can't multiply 3 times 3 to give us 5. Therefore, square root of 5 is the square root of 5, and we can simplify. It's not a perfect square. 4 is a perfect square because we can find a number that when we multiply by itself, we can get what's inside the square root, but 5 is not a perfect square. Now, let's say you have a bigger number. Let's say you have the square root of 64. Either you'll be able to think about it offhand and you'll realize that 8 times 8 is 64, so the square root of 64 is 8. Let's say you didn't know that. You could solve it on your calculator. You can press the second button, and you'll see if the second button is in blue. That means whenever you press the second button, the little blue letters over the buttons, that's what we're activating. So when we press second, if we go down to x squared, you'll see above it there's a blue square root symbol. That's what we're activating when we press the second x squared. Now we have a square root symbol. Inside we're going to type 64. And then enter. And it tells us the square root of 64 is 8. That's very useful if, let's say, you have the square root of 441. Now at first you might think, maybe this isn't a perfect square, but how do you know for sure? You can solve it on your calculator. Second x squared to get the square root symbol, then 441, enter, and tells us it is a perfect square. The square root of 441 is 21. Let's do one more on the calculator. Let's say we have the square root of 9801. Is this a perfect square or not? Let's do it on the calculator. Second x squared for a square root symbol, 9801. And the square root of that, 99. So 9801 is a perfect square. What would you do if you had a number that's not a perfect square? You would want to put that number into simplest radical form. Let's say we have the square root of 68. Before you start doing anything, you always want to check, is 68 a perfect square? So check on your calculator. Second square root of 68. Is it a perfect square? No. There's no number. We're only looking for whole numbers. There's no number that we can multiply by itself to give us 68. So 68 is not a perfect square. On the Regent, if you have an answer that's not a perfect square, they'll want you to put it in simplest radical form. To do that, we want to find the prime factorization of 68. So we're going to do 68, and we're going to divide it by the smallest number that's greater than 1 that goes into it. The smallest number that's greater than 1 that goes into 68 is 2. 68 divided by 2, if you don't know what that is offhand, you could do it on your calculator. But 68 divided by 2 is 34. Now we're going to take 34, and we're going to divide it by the smallest number that goes into it besides for 1. The smallest number that goes into that is 2. 34 divided by 2, if you don't know it offhand, you could do it on your calculator. 34 divided by 2 is 17. Now, the prime factorization of 68 is 2 to 17. What we want to do is, if we have doubles of something, we're going to circle that and leave that outside the square root. Whatever we don't have doubles of goes inside. And how do you know if you got the answer right or not? If you do you already did square root of 68 on your calculator. Now if you type in 2 square root of 17, If you get the same answer, you know that this is correct. Let's try another one. Let's say you have the square root of 315. Is this a perfect square? Try it on your calculator. Square root of 315. This is not a perfect square. There's no whole number that goes into it that we can multiply by itself to give us 315. So we're going to do prime factorization. 315, the smallest number that's greater than 1 that goes into it is 3. So you could do that on your calculator. What's 315 divided by 3? That's 105. The smallest number that goes into 105 that's not 1 is 3. 105 divided by 3 is 35. The smallest number that goes into 35 that's not 1 is 5. 35 divided by 5 is 7. So we're going to take our doubles and circle them, leave them outside. Only one of the doubles stays out, a 3. And inside, we're going to multiply our non-doubles together. So 5 times 7 is 35. So what we're really doing is we're putting in the 5 and we're multiplying by the 7. So we could actually do that, 3 square root of 35. And how do you know if you got the answer right? Well, we already solved the square root of 315 on the calculator before. So we know that's 17.748 ... Now what we could also do is we could plug in 3 square root of 35 and see if that's the same thing. That's also 17.748 ... Since these two are the same, we know that it's right. Let's try another one. Let's say we have the square root of 600. Is this a perfect square? Let's check. Square root of 600. This is not a perfect square, so we want to put it into simplest radical form. To do that, we're going to find the prime factorization of 600. The smallest number that's greater than 1 that goes into 600 is 2. 600 divided by 2 is 300. 300 divided by the smallest number that goes into 300 that's not 1 is also 2. 300 divided by 2 is 150. The smallest number that goes into 150 that's not 1 is also 2. 150 divided by 2 is 75. The smallest number that goes into 75 that's not 2 is 3. 75 divided by is 25. The smallest number that goes into 25 that's not 1 is 5. And 25 divided by 5 is 5, and that is prime factorization because there's nothing else that goes into 5 besides for 1. Now we're going to circle all of our doubles. We have 2 2s, the other 2 doesn't have a match, so we leave it outside, and we have 2 5s. So the prime factorization of 600 is 2 times 5, and then inside we have 2 times 3. Of the doubles, we only choose one of them, and we take those outside. And of the things that don't have doubles, we leave them alone and we keep them inside. We can simplify this more. 2 times 5 is 10. 2 times 3 is 6. So the square root of 600 is 10 square root of 6. How do you know if you got it right? We already solved for the square root of 600. So now solve for the 10 square root of 6. And since they're both the same, 24.49489,743, this is the correct answer. Let's do 2 more. The square root of 800. Is 800 a perfect square? It is not, so we have to put this in simplest radical form. To do that, we're going to do prime factorization. The smallest number that goes into 800 that's not 1 is 2. 800 divided by 2 is 400. The smallest number that goes into 400 that's not 1 is 2. 400 divided by 2 is 200. Smallest number that goes into 200 that's not 1 is 2. 200 divided by 2 is 100. Smallest number that goes into 100 that's not 1 is 2. 100 divided by 2 is 50. The smallest number that goes into 50 that's not 1 is 2. 50 divided by 2 is 25. The smallest number that goes into 25 that's not 1 is 5. And 25 divided by 5 is 5. This is prime factorization because there are no other numbers besides 1 that go into 5. Let's circle our doubles. We have double 2. We have another double 2. Our other 2 doesn't have to match, so we leave it there, and we have double 5s. So let's write this. We take out one of each of the doubles, so one of the 2s, and then one of the 2s from the other set of 2s, one of the 5s, and then inside we leave our non-doubles, and we can simplify this. 2 times 2 times 5 is 2 times 2 is 4, 4 times 5 is 20, square root of 2. How do you know if you got it right? We already solved for the square root of 800, so let's just see if 20 square root of 2, is that the same thing? And it is, so the answer is correct. One last problem. Let's say we have the square root of 802. Is this a perfect square? It is not, so we want to put it into simplest radical form. Let's do prime factorization of 802. The smallest number that's not 1 that goes into 802 is 2. 802 divided by 2 is 401. If you didn't know that, you could do it on your calculator. This is prime factorization for 802 because there's the 401 is a prime number, and there's no other number besides 1 that goes into 401. Since we have no doubles, everything stays inside. We have 2 times 401, which is just 802, and this is prime factorization for 802. There is nothing else we can do. So that's the answer.